Why, hello and welcome. As you can see, I have my good old calculator open and just paint. I was trying to figure out why more RAM with Windows or any operating system, the disk cache would begin to matter, and it also depends on what you're using it for. Um, this is just DDR5 6000 and 30 at 64 gigs versus 32 gig kit. If you're using as much RAM as I do, I don't have a lot of test systems, but I'm going to ignore the hard drive. It's going to be assumed to have no latency. Files are just instantaneously at the RAM. CPU, it's just instant, no bus, no hard drive, no CPU time whatsoever. No I.O. time. It's just going to be in the RAM. That's just the stick of RAM's timing. That's all we're going to look at. With Windows, if you're a power user like me, you need 64 gigs. Why? Because when you get down to 32 gigs and it's constantly pulling drive, just with this overly simplistic explanation, I'm leaving 23% of my RAM speed on the table. And this isn't scientific. This is just trying to get a general concept of why you need more RAM before you need faster RAM and why it adds up. Is that 6000 has to pull the same file twice before I get to use it sometimes, or a lot of the times it gets pulled in and out, which means that it's no longer 11 nanosecond RAM, it's 22. Due to the number of times that file has to be pulled back into RAM over and over and over again. That starts to add up. And if you went to 16 gigabytes and you were me, that number would probably be about 40 or 80 because of the number of times it's the Windows disk cache just being used over and over and over again to try to balance everything. So yes, more RAM, then faster RAM. If all you're doing is loading 3 pictures, 3 web tabs and a few pictures on occasion of the dogs or some neat painting, fine. You need 16 gigs of RAM, you're fine. If you're gaming, just basically it's a boring old office PC. You don't even need really a GPU for that anymore. Just don't get an F series. From either AMD and Intel, because then you don't have an APU. If you're doing light gaming, you need 32. But that's assuming that you have turned off your web browser, closed all your social media, your Discords, everything is off. If you're leaving your web browser open and talking to people and gaming, you're beginning to need 64. The disk cache will start to really hurt your performance at that point, in that it will be constantly fighting for time in the RAM. And if you're running new titles, yeah, you need 64. It's just RAM is faster than your hard drive, even these modern SSDs, and RAM has a much higher rating for wear and tear than your hard drive. And, well, leaving 23% of your performance on the table, that explains why when I upgraded a PC that is used as a power user, it acted like it got a CPU upgrade. The disk cache was eating that much of the performance. And I just booted up the turn spinner on, the demo loop on Three Kingdoms, which was not exactly fast on a Ryzen 5600X, very playable. It was like, whoa, I can see the difference in this game. Yeah. More RAM, then faster RAM is your priority, because the base speed, due to how it's utilized, is hammered. You're double loading versus single loading, and suddenly, yeah, it's 6 nanoseconds, but you didn't save any of it. It's now 22 in just this case scenario. I just quickly looked up like a single stick of higher end RAM that I have, like would have been recommended to me, and for the sweet spot on Ryzen 6000, and I went, well, what happens? And I went, ew. That's a lot of performance that is a CPU upgrade almost. I have seen that work miracles on computers having enough RAM. I mean, there's feature support, but it's the same with graphics cards. If you don't have enough RAM, you run into the same issue. It's caching, except it's even worse. Anyway, you now know why in very vague terms, because this is what happens when you have to load a file twice. Not very speedy, snippety, whatever it is. I'm tired, I'm up late. And, well, 23% performance left on the table. This is only 77% as fast. This is only as that. That is scary. So yeah, go get 64 gigs for your Windows 11 machine, match the CPU spec. You'll put it on the board, it will work, you won't have to fight with settings. And I'm still going to stick with my recommendation. Look at your CPU and just match the RAM speed, what it says is max. Because it's the headache-free way of working. And I did pull up Tech PowerUp, and it was a 1 or 2% difference. To really go higher, you really weren't noticing it overall. More, though, that looks like it has more performance gain for less money. And it's definitely a more stable computer, and your boot drive will last longer. And that's a lot more expensive in the end. Anyway, hopefully this helps someone out there. Not sure I can put for a thumbnail on this, but anyway, I'll see you guys next time. Hope you helped the end. And thanks for those who stopped by.